In between.
No, in between.
That's
I
one
said
word.
in between. If
I
B
don't
is somewhere in between A and C, then A plus B plus
Obviously,
BC.
if I wrote it down, it's too late on the slide.
Congruent test objects that have.
I'm really
same
What's up, Ben?
Postulate 3. Protractor
Hello.
postulate. Angles. What?
Can you hear me?
I can.
Oh, I didn't write that whole
Alright, okay, good.
Property of algebra. A plus B equals A and C. What? If A plus B equals C, wait, A plus B equals
If A equals B, then A plus C equals B plus C.
Well, I don't have time to say the entire word.
You can just skip over things and it doesn't make sense.
Yes, I can. Look, I'll skip over this thing real fast.
This homework
Page
was pretty
1
obvious.
through 18.
I started doing
That's
9
it. See,
before I
look,
did
page
10,
118.
Find your seats. Let's get going.
before I did 9. And then I did 16 before I did 15. And then I
See,
did
I'm a math. Wait, what?
Math something or other. All right. Any questions on the homework?
9.
Well, I think I got some of the multiplication wrong. Or subtraction, addition, other stuff.
Was there anything you got right?
Yes, the formula.
The
You
what?
got the division right.
The formula.
7.
7.
Let's see. If McKinley can get, how many did I give you?
12.
18.
You can get 10 of them correct. We will have no homework tonight.
Okay.
That's not fair.
What did you do?
Actually, wait, no, that is fair. Let's just see if McKinley fails 8 of them, and then if he fails the 9th one, we can all laugh at his face.
All right. Go ahead, McKinley. Number 1, the answer is 3-9 is correct. Oh, we might not have homework tonight. Go. Number 2.
Wait, 23rd?
923 is correct. You got 2 right. Number 3.
Negative 16, negative 8.
Uh-oh, Mr. C may have made a bad bet.
0.6.
I'm confused.
That's your first one wrong. The answer is 922 for 4. Number 5.
I'm pretty sure I got this one right, but 308 is 44.
No.
Okay.
28-4 for number 5. Number 6.
Dang it. 4.
No. -4, -4.
That's what I thought, but
You just dropped a negative, clearly. Number 7.
19, 6.3.
1-6.
Yes.
Number 8.
54, 8.6.
No. 6, -1. Number 9.
Should I start my homework now?
There's still a chance.
We're on a roll.
We're only up to 9. There's 9 left. He's got 3 right. We can get to 10.
Negative 25.
Well,
No,
Mr. C, Mr. C,
Number 10.
4,
10?
Yeah.
What'd you get?
1, 4, 1.
It's really close.
So close.
4-0.
No, I got it right.
You got the first part right, the second part wrong.
So I got the half plus.
Number 11.
3, 2.
Oh, no. -2, 3.
Negative 2? Who said all these negatives came in here?
Number 12.
One negative
Number
4.
12. 1 -4. Yes, you're up to 4.
Yay!
We have 6 left, and you got 4 right. You got to get everyone right.
Oh, no.
Wait, what number failed?
McKinley, if you fail one, you lose.
All right.
What? No, it's not 1 -4.
Yes, it is.
And a half.
What is?
Yeah,
All
he's at 6.5.
Yeah.
Wait, what is number 12?
Number 13.
-4,
Twelve.
-1.
You just dropped a negative. It's 4-1.
Dang it!
All right, so we lost.
So
the
he's
bet.
at 7 now. Because he had the half and then the other
Oh,
half.
I don't know about that. We gave him a half because one of the numbers was correct. Now neither of the numbers was
Yeah, they
correct.
were. They were close enough.
I didn't believe that would be
14.
Oh, no. 14, -73.
No.
What?
2 -1. All right. 15 is 6-2. 16 is 0-5. 17 is 11-16. And 18 is
3, 4.
close. 3-2.
Well, I got 16 and 17 right.
What is
That's
number
good.
2 again? I didn't hear you when you guys were going over number 2.
Number 2 is 923.
Number 2?
Number 2 is 923.
923.
I bet what you didn't do, which is what everyone else did, when you substituted 2x plus 5 in, you made 2x negative, but you didn't make 5 negative.
Oh, well, I'm just gonna.
What? Oh, yeah. I'll take that back.
That would be.
Alright,
I mean,
I
this
got
is-
one wrong, and I feel ashamed of myself.
All right, I need to find. Handouts. Ruh-roh, Raggy.
So we don't have anything.
So did I throw them away already?
We have like a reading. I count this as an absolute win. So.
No, he said that was just for reference.
And then nothing else, right? We have ancient lists,
Aha!
history,
I did not throw them away.
everything else we don't have anything except for math.
We're gonna have homework for math.
We have
You
now
almost
ancient
didn't
lists.
have homework. All right.
Well, can I make a new value to you at number one in geometry if I get all of those right?
Oh, there's a lot of
Well, there's a
that.
proof to do here.
Okay, but
Oh, yeah, if you get the proof right.
We might not even do the proof. It's up to you if we do the proof or not. You'll see why.
Proof.
All right. Let's see. We got quiz on next Wednesday. Quiz next Wednesday. Here's your homework. It's weird. I skipped around a little bit, but period 2 already started, and I'm like, oh, this is easy. And this one is easy. The homework is easy. The class is, there's a lot of stuff to write today. A lot of stuff to write.
I don't like writing math. I leave writing to writing class.
There's a lot of stuff, but it must mean it's easy.
Plus it's
Agreed, it
math.
is. And technically, everything that I will teach you today, I mean, literally everything I taught to you in pre-algebra. There's nothing new today.
Yeah, they go away. Sorry, my
Yeah, but some of you don't remember it, so.
Well, I don't remember it, but I'm pretty sure I could guess it. But not
I
to
remember
get
how
by.
to do
Do we need our little book of truth today?
Oh, yeah, and everything's going to the Book of Truth.
Got it.
Oh, no.
Everything's going to the Book of Truth.
Moderating.
A lot of writing.
You want us to turn this on again?
Let me just see it. Oh my word, that's horrible.
I'm sorry, it's too
What happened to you, neat Jack? You used to not be that bad.
Where are the problems were in order?
Well,
You used to be neat.
I was doing them in class, and then he was doing the answers, so I'd like the answers off to the side.
Why would you
Hey, I'm neat.
No, Ben, you're absolutely one of the neat ones. But Jack, not so much.
Yeah, I'm the worst person.
No, you weren't that bad the last 2 years.
Yeah, I'm bad this year.
Okay, so there's gonna be a lot. I mean, I'm not joking. A lot of writing. So it says definition. So we are gonna do one theorem, but everything is pretty much a definition. All right. So you remember this from pre-algebra?
Yes.
All right.
No.
Tell me what I'm gonna say.
Well, parallel lines are like that,
Okay.
and then screw lines are like that.
Like what?
Across. They go across at one point. Okay?
So like this.
Yeah, like that.
This is skew.
No,
That's skew?
That's an X. Not like that. It goes across one point in time and space.
Well, this is intersecting lines. This was from chapter 1 and 2.
Oh.
Skew
What's
lines,
skew
like the
lines?
Same line.
Are they lines that curve, but lines can't curve, so that
They're
can't
not
be it.
parallel?
They're not parallel, and they're not intersecting. How is that
They
possible?
eventually intersect.
They never intersect, but they're not parallel.
They go across like this way. At
You ready
the
for
very end.
magic?
Oh, they're
Ta-da!
It's called when it's a curved line.
All right. So it's not curved, although that is a possibility, just not in this geometry. So check it out. If 2 lines are parallel, they must be.
Across.
They must be. Why did I put it up against the board?
Straight.
They must be.
Right.
Must be.
Straight across. They go on forever.
She was closest when she said flat.
Because they're parallel.
On one plane.
They got to be on a plane, so they're coplanar. So parallel lines must be coplanar. How about intersecting lines? They also must be.
Go fighter.
They must be coplanar, right? Skew lines are
Non-co.
non-coplanar lines that do not non-coplanar lines.
But
I'm
how
gonna
do
leave
you
it at that.
know that? It's the
Because they could be like this, but as soon as they're coplanar, they're either parallel or they're intersecting. But they're non-coplanar lines, right? They don't have to be this. I mean, but as soon as you put them like this, then they could be on one plane. Right? All right, so we're going to be talking today about parallel lines mostly, but also skew lines as well. All right, so first definition is parallel lines. Coplanar lines that do not intersect. So coplanar lines that do not intersect. Because remember, they could be coplanar and intersect. One plane contains both lines that intersect. But parallel lines are on the plane, they just don't intersect. We will refine this definition later in the chapter. Yeah.
And Charlie and the Chocolate Factory, what's the probability of it all going to the same, almost the same exact age kid?
What?
Well, all the tickets go to the same age.
Age kind of kid, yeah.
Oh, good point.
Well, probably
Good
because
point.
the parents gave it to their kids.
Good
Well,
point.
only one ever did that. The rest just.
No, good point. Good point. I never thought of
Actually, it
that.
wasn't the parents. I think it was the parents.
That's what it is. The granddad is the one that actually gets the chocolate bar and gives it to the son.
Yes,
The
but I'm
grandson.
talking about the rich girl.
Granddad wasn't the one who discovered it. He bought the
He bought the chocolate, and granddad who had
He
a
bought it for his son's birthday.
grandson.
Grandson's birthday.
And he suddenly becomes unbedridden just because he can go to a factory.
And just like all Disney movies, although I'm not sure if that is a Disney
I don't think
movie,
it is. It is.
just like all movies about kids, for some reason something happens to the parents.
Why?
I don't
Yeah, like
know.
they're-
It's like all Disney
Yeah,
movies,
we
one of the
were-
parents is dead,
Like
and
We
Yeah,
were
it
trying
is.
to
Until
find
they
a
die.
movie where
They're
one
not
of the
dead.
parents isn't missing or dead.
Same thing with Charlie and Chocolate Factory. All right, parallel lines, coplanar lines do not intersect. There's a nice picture. Just remember in our book, if the shape is colored, they're trying to tell you that there's some 3 dimensions going on. In other words, there's a plane right there. Yeah, there's nothing much going on in that picture. All right, next one. Oh, by the way, that's the symbol for parallel. Lines can be parallel. Skew lines are non-coplanar lines. Well, you can kind of just leave it at that. I mean, it does say that don't intersect. There's no such thing as non-coplanar lines that do intersect. The book does say this. I'm just going to tell you that you can't, if they intersect, then they are coplanar. If they're parallel, they are coplanar. All we got to say is 2 lines that are non-coplanar. But we do have to be careful with that. And the reason why the book says it is this. If you put 2 lines on 2 different planes, right, and then you make those planes parallel to each other, then, I mean, granted, there is one plane that contained the 2 lines, but if they were originally drawn on 2 separate planes, I mean, that's where they get around this that don't intersect. Okay, so technically, you drew the lines on 2 different planes, right? Just remember, if they are parallel or intersecting, one plane could contain the 2 lines. This is where it gets into really messy true and false questions, and I kind of steer away from the really messy ones.
True and false questions. Why are we still doing true
Right,
and false?
this is a horrible picture. This is what's in your book, right? And I made it that small because I don't even want you to look at it too much, because I think the picture that I showed you is the best picture that you keep in your mind, a 3-dimensional picture. It's showing that it certainly looks like they intersect, though, and it's because of the way they have to draw it. They have to draw it in 2 dimensions. So it doesn't matter where I put this line K, left, right, turn. It's going to look like it goes through the other line because the way it has to be drawn. But if you notice, there's a dashed line, so it's trying to tell you, hey, it does not intersect. The dot is right here instead of right there. Okay. Some quick notes. Lines have segments in them, right? Line AB has in segment AB. It also has ray AB and ray BA. So it has lines. Lines are made up of segments and rays. So if I give you 2 lines that are parallel, what do you know about all the segments and the rays that make up those 2 lines?
Parallel.
They're also parallel, correct?
Well,
All right,
can't there be a line that goes through E and B?
That would be a different line.
Oh, that's
Right.
different.
But-
But technically it's parallel to another
It's
line.
not one of
That could
those.
happen. Certainly could happen. But if I take something that's made up of line AB, then necessarily it's parallel to whatever you want to describe in CD. All right, so we get all of these statements right here. The 2 lines are parallel, rays are parallel, segments are parallel. All right, intersecting lines. I think I've done this, enough that 2 lines intersect. They intersect at one point, and it's got to be on one plane. All right, intersecting lines. They are coplanar, right? They only intersect at one point. Non-intersecting lines, though, we got different possibilities. What do we know about non-intersecting lines?
They can be parallel or skewed.
They can be parallel or skewed, so that means they could be
Coplanar?
coplanar or non-coplanar. As soon as you get to intersecting or parallel lines, coplanar, that's it. There's no other option. But non-intersecting lines, you have two options, coplanar or non-coplanar. If they're non-coplanar, necessarily they are skewed. All right, and they can intersect at a point. That doesn't mean they can intersect at 2 points. It just means that this is the statement being skewed, right? Sure, if they're parallel, they're coplanar. And if they do intersect, they intersect at 1 point. That's a bad statement. Ignore that. That shouldn't be on this right here. This should say they're skewed.
Did you make a?
Well, no, if they intersect, then they're coplanar. That statement's bad. Okay, so this is kind of the more important one. I put this in box 1. And the basic idea is this. If two lines intersect, does that mean that all parts of them intersect?
No.
It doesn't, and that's what they're trying to stress here. So look at the picture and tell me what they're trying to say.
The line PQ and line RS intersect. Yes.
But
Yeah.
No, the segment does not intersect.
segment, these particular segments, there could be segments of PQ and RS that do intersect, but as drawn, the black segments there clearly don't. So what do we call them then? We're talking about segments, and this also applies to rays. If they don't intersect, and they're not parallel, and they're not skew, we don't have a name for them. We just say they're non-intersecting segments, okay? So we don't have a special name for this scenario, where the two lines intersect, but the pieces right here do not intersect. But they certainly are coplanar. They're clearly not parallel, so we can't say they're parallel. We can't say they're intersecting. We can't say they're skew. There you go. Become a great mathematician and give them a special name for that, and you'll teach generations of kids. All right, let's answer the questions. Does segment PQ intersect RS?
No.
Yes. Ben?
No.
Okay. Does line PQ intersect line RS?
Yes.
Yes.
Is line PQ parallel to RS?
No.
Why?
No.
By the definition
intersect.
of parallel lines, or the definition of intersecting lines. Either one would be. By the intersected parallel lines, you're parallel if it is a biconditional, if and only if you don't intersect. All right.
And the last one.
No, it's not biconditional because it could be skewed. Never mind. And then segment PQ is clearly not parallel to RS.
So I'm right. I'm a math genius now.
Okay. How many did you get right on the last homework?
I got formatting here.
You don't please say Einstein had bad grades.
I don't believe that for 1 second. I mean, that's the same thing they say, well, he never graduated high school. Because he didn't go, he skipped right to college. Right? Neither did Bill Gates. Bill Gates and then Steve Jobs, they didn't graduate. Neither did the Facebook dude. He didn't graduate college either.
Well, why is all these people not graduating?
Because they didn't need to. They were too smart for their own good. All right, first definition, parallel planes. I need my demonstrators. All right, parallel planes. You can probably figure this one out. Parallel planes, if you have two planes that are parallel, that means they do not intersect and they're parallel, like this, right? Two parallel planes can be twisted, turned, any way you want, okay? Parallel planes. So those are planes that are parallel. How do we name planes?
Plane.
By 4 letters. 3 letters.
3 or 4 letters, or by 1 letter, right? If the 1 letter is kind of like floating around, usually the letter is off to a corner, but here they got smack dab in the middle. It can be called. So this is plane X and this is plane Y. And basically what they have is they got a rectangular prism that's talking about the top and the bottom. Oh, by the way, how many surface area? How many parallel planes do we have here? Surface area.
4. No,
2
3.
3 pairs.
3 pairs, right? Left, right, top, bottom, front, back. What?
I think it's cool.
Okay, so the way you say that 2 planes are parallel, now we could have said EHG is parallel to ABC, but since they have that 1 letter, it's more convenient to say X is parallel to Y. This is a hard statement. Here's what it's saying. It says that anything, literally anything on this plane is not parallel to anything on the other plane. It's parallel to the plane. So for instance, I mean, I could prove that is not parallel to that, right? So it's not saying that anything on this plane is parallel to anything on the second. It's saying that this is necessarily parallel to the plane.
Anything on X or Y is either skew or
No.
parallel. Anything on X to Y.
Right, but they're basically what they're saying is they're comparing a plane to a shape of some sort. And what they're saying is if you have two parallel planes, then any shape on one of the planes is parallel to the plane of the second one, or the second plane.
So
Don't confuse this with anything on the first plane
So
is
where
parallel
you
to
go.
anything on the second plane.
but if they're parallel, doesn't that mean they're technically coplanar? And they can't be coplanar.
Well, if they are parallel, then remember we're talking about a plane, so
Right. They can't be
right.
coplanar.
All right. So that is a troublesome statement, but that's the explanation of it. All right, so here's what they're basically saying. You see where EF is? EF is on X, and since X is parallel to Y, then EF is parallel to plane Y. Ray HG.
Wait, technically,
So
don't you have to say plane Y?
you do, because it's descriptive. So ray HG is parallel to plane Y. And line FG, right? Now, what do you know about FG and AB? FG and AB.
They're skew.
They're skewed to each other, right? Those are kind of like the questions you'll see tonight. All right, I forgot what, oh yeah, the proof. All right, the proof says this. I usually choose not to prove this particular one because it's pretty simple. All right, demonstrate it. All right,
X is Y.
you're going to give me two parallel planes. Two parallel planes. So you see the two parallel planes, right? I'm going to intersect those parallel planes. What shape does it make? Remember, shape means where they touch each other. What shapes do we make?
Yes, that's enterprise.
We get one line or we get two lines?
Two lines.
What can you tell me about those two lines?
They're parallel.
Yeah, that's what the theorem basically proves. And most people will just look at that and say, well, obviously, if the two planes are parallel, then the two lines must be parallel. This is Theorem 3.1. There is a proof to it. I'm going to skip it. If you'd like to go over it, we can, but I'm going to.
Wait, although even if, so if you're looking at that, if you twist X and Y towards each other, L and N are still parallel.
Remember, you can't twist a
If
plane.
you do this,
You can tilt a
so
plane.
if you tilt the plane and you tilt the
Then
plane, and they're still parallel.
They're still parallel.
So then how do you prove that?
Well, remember, as soon as we say that they're parallel, then they're fixed in space. So there's no twisting allowed after you say one is parallel to the other.
Fine, tilting.
Right.
So if you took that diagram, you know what I mean? If
It
you
would
tilted-
still make two lines, and the two lines would be parallel.
Right. So then how,
Not the same two lines. They would be
So-
different.
so as long as those lines are coplanar and the Z coordinates are straight.
As long as you have three planes and one plane intersects the other two, then you're guaranteed to have two lines, and the two lines must be parallel
No,
to each other.
no.
You tell me the only way that that could not happen is if I take this and twist it like this,
No.
and then it's not a plane.
No, because the lines don't have to be parallel, do they?
Well, tell me how. Here's the two planes. Tell me how you can twist it so that they're not parallel. Look, I'll hold these. Here's your two parallel planes.
I can put this guy up like this.
Okay, then this guy's got to be like
No, it
this.
doesn't have to be though.
Yes, it does, because that's the start. If two
No,
planes are parallel,
I'm saying, what if they're not parallel?
then this one doesn't apply.
I was.
So remember, the if part is always true. So if plane X is parallel to plane Y, that's the starting point. All right, so let's write this one down. This is Theorem 3.1, and it says this. If two parallel planes are cut by a third plane, then the lines of intersection, because remember, planes intersect at lines, then the lines of intersection are parallel. Will we use this one occasionally? Probably, I don't know, 2 or 3 times in the whole book. And then the pain becomes real. Now we're getting some pain. If I do not get through the whole thing, you're still responsible for this.
Wait, what?
But I think I'll be able to get through it in 10
What are
minutes.
you talking about?
Well, you'll see here in a second. This was the easy one, right? And the rest are just definitions. And I said I already taught this to you. Now, clearly, I didn't teach this to you in pre-algebra. But the rest I taught to you already in pre-algebra. And they're just definitions. And you guys probably could already tell me once I tell you the name. All right, ready? All right, this is not only big, this is huge. And it's very important. And for some people, it's painful. All right?
Some of it causes excruciating pain.
Some of it causes.
And that's the
So
only
here's the
thing.
idea. You take two coplanar lines, two lines that lay on a plane, right? Well, 1, 2, and guess what you do to it?
Connect them, put them together.
You cut them with a third.
Oh.
This is the pain right here. Right?
How though?
This is the pain. This is the pain.
Oh, what the?
All right. So lots of definition based on that one construction. You don't remember this from pre-algebra?
No, but I'm more worried about
Two
that
lines
one.
cut by a third. Do you remember what we call the line that cuts the two? Start with a T.
The
It'll be our first definition.
trisector.
It is called a transversal. Now, it doesn't have to cut 2. It can cut 3 or 4, but it cuts at least 2. So you get 2 lines that are coplanar. The third line cuts it. Well, that makes the third line also because it intersects. We are going to consider it also coplanar. Now, there is a construction where it is not coplanar. We won't consider that one until later in the chapter. If you take L and H and you twist them, well, then they're not coplanar to start with. So we're only going to consider the case where H and K are coplanar. All right. You don't remember this still not? How many angles do we make?
8.
You don't remember it yet?
What? Why do you make
We did this in pre-algebra.
16. You make 16 lines. 8 angles.
Well, you make lots actually more than 16, but we're going to consider just 8 of them. Okay? So what we are going to consider is that. And there's more, right?
Excuse me?
Yes, ma'am.
Is David Wehrlein there?
No, he is not. We're on Friday schedule.
Okay, thank you, that's right.
All right.
Oh,
Okay. Here we go. First one. Interior angles? Yes?
Oh,
No?
Yes, yes, yes.
ulterior internal angles, corresponding angles, same side
All
angle.
right. It all comes flowing back, right? So which ones are the interior angles? Take a guess, McKinley.
3, 4, 5, 6.
You got it. So those are the angles between the two lines, not the transversal, but between the two lines. So that would be what, 3, 4, 5, and 6. Those are the interior. They're just names, just names.
But why would they do this to us?
Oh, you'll see why. This whole chapter is about this one shape right here.
But why do I need to know about this one shape?
We're going to
It has no
use
purpose.
this. We're going to use this a lot this year. Okay, what's the next one?
But it has no purpose in the middle.
Oh, yes, it does.
Okay.
Carpenters use this all the time.
Carpenters. Are
What?
you gonna be carpenters?
Well, we do have exterior, but they choose to talk about them later. They're going to talk about some of the special interior angles.
Same side interior.
Oh, these ones and these
That,
ones.
yes, and those were called.
The X.
All right. So my
Exterior
teacher
angles.
said, look at one of them. It starts on the top. I would need you to alternate. Now I need you to go to the bottom. I started on the left. I'm going to go to the right. They're called.
Left, right angle.
No, they're called alternate interior angles.
Oh,
Alternate interior angles just means they alternate. Instead of being on the top, they'll go to the bottom. Instead of being on the left, go to the right. But remember, they're interior. So we're still talking about angles 3, 4, 5, and 6. But we're going to pair them up now with their alternate. Instead of 3, we're going to 6. Instead of 4, we're going to 5. So those are the two pairs of alternate interior angles. I think there's 6 of these we have to do.
Oh God.
So these are the ones, if I don't get it down, you're going to have to read through your book and get the other names. And I'll cover it briefly on Monday. Okay, what's the next ones? Take a guess, anybody?
Exterior angles,
We will finish with corresponding.
same
There
side
are
interior angles.
exterior. We're going to talk about more interior. There's one other set of
Same
interior
side?
angles. Yeah, they're called same side interior angles. So we're still staying on the interior. These are the last ones for interior. And we're going to talk about angles 3 and 5 and 4 and 6. They are called the same side interior. And we're going to be able to say something about this. I don't know if it's next class or the following class. I think it's next class we do same side interior. So we got same side interior. We also have same side exterior. So for the inside interior angles, basically all we have is alternate interior and same side interior. That's it for interior. And now we'll talk about the exterior angles. Okay? All right, the first one is the alternate exterior angle. So which ones would those be? Alternate exterior.
Wouldn't you have to do exterior?
I know, and the book just doesn't give it any love at all. It's like they define interior, but they don't define exterior. That seems kind of silly. Yeah, the alternate exteriors would be 1 and 8 and 2 and 7.
It says two non-adjacent interior angles on opposite sides.
2 non-adjacent. Blue is non-adjacent to 8.
Yeah, it says
2 non-adjacent. Oh, that's wrong. Good catch. Good catch. Nobody caught it last year. Oh, they might have. Nobody interior, exterior. That's better. Nobody caught it this morning either. 2 non-adjacent exterior angles on opposite sides of the transversal. That is correct. That's all right. I put a T instead of an X.
Jack gets
All right.
Jack gets a point.
1 and 8, 2 and 7. Same side exterior. 2 and boy, did I mess this up. I haven't used these particular slides for more than 1 year, so I started afresh when I started teaching geometry here. Plus, the previous book I taught from didn't follow the same patterns. That's exactly what I did, right? And I just didn't change the word because the same side exterior and same side interior, it's the same definition except for the word exterior. And we got one left.
It's almost 2. We have to hurry.
I know. What's the one that we left off?
Same
Exterior.
There is same side exterior. For some reason, our book doesn't talk about them. We'll talk about them when we get there. The last one is probably the most painful one, and it's called corresponding.
Oh, I don't remember these, but I'm pretty sure.
All we did in pre-algebra was corresponding and alternate interior. Corresponding angles are angles in the same position relative to the 2 lines. And I put in parentheses there, this is in the book, same side, same position. So what it means is pick any one of the 8 numbers. Pick one, McKinley.
3.
Look at 3. It's in the lower left-hand side. You see it? Which other one is in the lower left-hand side?
5 or 6.
How about 7?
Oh, okay.
So these are the painful ones.
Go away.
So for you non-colorblind people, they're the colors that match.
Yay.
Supposedly, I don't know if it's cats or dogs.
Yeah.
Yeah.
Wait, does the guy who made Google actually graduate college?
Sergey Brin and who's the other guy? Sergey Brin and I forget the other guy's name. I believe they from Stanford, I'd want to say. Because it's one of those prefixes that means a billion, trillion, gazillion, a Googleplex.
Yeah, a Googleplex and a Google.
Yeah.
So there's like, yeah.
I assume it just means they have so much knowledge that I don't know if that's.
Well, Google is
Googleplex is the biggest number in the world.
Well, add 1 and there's the next biggest number.
Oh, right, but the next biggest number.
Right. All right. So these are the corresponding angles: 1, 5, 2, 6, 3, 7, 4, 8. I'll just say most math books literally label them the way I label them. 1, 2. You can see how I label them. they don't have to be labeled that way. So don't say, oh, look, these numbers are 4 apart from each other. That's all I remember. No, that's not a good method. Do the McKinley method, which is you pick a number and you say, what position is it in? Upper right, upper left, lower left, right? And then just find this one down below that's in the same position. All right, I did finish on time. What do you know? So all they're gonna have you do for this homework is identify some things. We're gonna get, I'm not lying when I say we're gonna get just tons of theorems from these. So much so that you will be a little bit swamped in this particular chapter. And plus, we're going to do some real proofs in this one.
Sure.
Ben, do you have any questions?
Oh.
Yes. Are we doing classroom exercise or written?
No, I'll go to the homework slide. It's written exercises.
Then why does it say page 75, which happens to be classroom
Mine
exercise?
says 76. Did I make a mistake in?
No, go back to the slide you were just on. You said 75.
Yeah, but that was for if we had time in class, we would go over the classroom exercises.
Oh, okay.
Wait, corresponding angles I can do.
Well, not the ones that I showed you, but yes, that's one of the ones we'll prove. Yes. So on Monday, what we're going to say is, look at me. I gave you H and K like this, right? And then all of a sudden we're going to say, well, what happens if they're parallel? And cut by transversal. No, it's not true.
Why not?
Well, I'll just draw a basic shape.
Oh, right. You're right. I was thinking of.
You think about this one is acute, but that one's obtuse, so they can't all be.
Yeah.
Now, they would be if the transversal is perpendicular. Okay? That would be the only
Yeah,
time.
but if you think about it, if you're looking at both of the angles are at 180. Vertical lines are congruent, so therefore the corresponding angles are congruent. Because the vertical lines are congruent, each and every.
You're only missing one piece to make that proof true, and you're almost there. But we will certainly use the fact that they're complementary next to each other and they're vertical. But the question is, how do you get from this angle down to here?
Attention students and teachers, dismissal is about to begin. At this
If
time,
these two are
please
congruent,
dismiss all
this guy,
walkers,
this guy, and
bike riders, and front pickup.
this guy,
Walk.
Please hold SAP kids and
because
YMCA
they're
until
both
dismissed.
congruent and they're both
And happy Friday.
and transversal straight line.
Happy Friday, I got
Closer.
a run for
You're closer.
3 miles.
That's
I'm
better.
not happy right now.
The last part that you said. The fact that transversal is straight.
Yeah.
Hey, stack 2 chairs. 2 chairs. And I'll stack the rest.
So I have a question.
Ben, what's your question?
Can you go to the slide where it defines same side interior angles?
Sure can.
Same side. Okay, thank you.
All right. There was a mistake on the exterior angles. All right, Ben, you have a good weekend. We'll see you on Monday.
Bye.
Later.